A very good morning to one and all present here. Today, I, Mansi Ganu, welcome you all to the inauguration of PICT Chemistry Virtual Lab. I would like to begin with a shlok. Nahi jnanena sadrusham pavitram vidyate. This shlok translates to, nothing is more sacred than knowledge. In these challenging times, when the entire world came to a standstill, the wheel of time still continued to go on. And this pandemic has reinforced innovation in education and reinforced how our utmost priority is to ensure that there should be no hindrance in the learning process. Keeping this thought in mind, the idea of a chemistry virtual lab came into picture. After many months of hard work and continuous and constant support from our teachers and college, we were successfully able to implement the project and present it to you today. With deep respect and enthusiasm, I welcome our Honorable Chief Guest, Dr. Guruswamy Kumarswamy, our guest of honor, Dr. Sudhir Agashe, respected Principal Ma'am, Dr. Srimati, Director of PICT, Dr. Prahlad Kulkarni, Head of First Year Department, Dr. Reddy, and Virtual Lab Team Leader for this project, Dr. Bhavna Vyas, respected teachers and all participants for the inauguration of PICT Chemistry Virtual Lab. I would request our Chief Guest, Guest of Honor, Director Sir, Principal Ma'am, and all dignitaries to proceed for Saraswati Puja and Deep Prajwalan. Honorable Chief Guest Dr. Guruswamy, with your permission, we would like to begin with a ribbon cutting ceremony. Thanks a lot, sir. With immense pleasure, I would like to introduce the team leader of PICT Chemistry Virtual Lab project, Dr. Bhavna Vyas. And while today's inauguration ceremony falls on International Women's Day, I take pride in being a part of this project, which was originally her brainchild. It would have been impossible to implement this project without her. She has been the driving force to take this virtual lab project from ideation to execution and is the backbone of this project. She has a rich 25 years of teaching experience in PICT. She has completed her PhD in Chemical Engineering from IIT Kanpur and Masters in Chemical Engineering from IIT Bombay. Along with this, her research is published in the reputed international journal called Soft Matter, and she has also participated in various national conferences. As she calls herself a humanitarian by heart, it comes as no surprise to those who know ma'am that she is also involved in social work. Bhavna ma'am is the founder of Pari Udan, an organization that provides scholarship to girl students for their education in rural parts of Rajasthan, India. Ma'am, we would love if you could share a few words about the virtual lab development project with us. Over to you, ma'am.
Thank you, Mansi. So, good morning, everyone. Myself, Bhavna Mukesh Vyas. On behalf of my team, I welcome our respectable dignitaries, Honorable Chief Guest, Dr. Guruswamy, Guest of Honor, Dr. Sudhir Agashe, our Director, Dr. Prahlad Kulkarni, Principal Ma'am, Dr. Srimati, Head of First Year Department, Professor Reddy, Head of Computer Department, Professor Mukta Takrikar, Head of ENTC Department, Dr. Sandeep Gaikwad, Head of IT Department, Dr. Anand Bagade, all functional heads, my dear colleagues, and all the participants in today's inaugural ceremony of PICT Chemistry Virtual Lab. Today's day is a very special day for me, as 1 year ago, the idea of a virtual chemistry lab was just an idea. And today, all of us are here to witness the lab functioning virtually and fulfilling the objective it was designed for. Let me take a few minutes and share my journey of bringing this idea to the life. We all have been impacted by the pandemic in different ways. For us, teachers, it was no less than an examination where we were unaware of the syllabus, the pattern, or the outcome of this exam. We were right in the middle of the working semester and we had to shift the classes to online mode. While teaching theory online went just fine. But imparting the practical knowledge gained by conducting the experiments was a challenge. Challenges are where the needs reside. And needs are where the ideas ignite. So I started looking for the ways my students could gain this practical understanding and came across a couple of virtual laboratories. The chemistry experiments available were not mapping with the SPPU syllabus. That gave me an idea to develop the PICT Chemistry Virtual Lab with the help of our very own PICT talent pool. Our respected director, Dr. P.T. Kulkarni, has seldom mentioned this line, forgive me for paraphrasing, something like, if everyone will download, who will be the one to upload? Which acts as a fuel to the burning fire to create something new, that is to upload. Yeah. While planning the lab, I realized that this would be a great opportunity for our UG students to learn and apply their technical skills. I floated this opportunity in the college, and out of so many interested students came the most sincere, dedicated, and tenacious bunch which today presents the virtual lab before you. With pride, I would introduce you to the PICT Chemistry Virtual Lab team. Pratik Dahigavne, Rohit Pardesi, Prathamesh Shiralkar, Yash Kale, Farhan Nakvi, and Manasi Ganu. They have consistently worked hard, managed their curriculum, extracurricular activities, and internships as well along with this project. Their creativity, sincerity, and a constant willingness to do better made this journey a thrilling experience to me as well. After the development of PICT Chemistry Virtual Lab, we approached the principal investigator virtual laboratory project of Government of India, Ministry of Education under National Mission of Education through ICT, Dr. Sudhir Agashe, who is from CUAP Pune, to upload the PICT Chemistry Virtual Lab on MHRD website. And I'm glad to share that it is under process, and our lab will be available for a wider audience shortly. I take this opportunity to thank our Managing Trustee, Shri R.S. Kothavle, Secretary, Shri Swastik Sirsikar, Director, Dr. Prahlad Kulkarni, Principal Ma'am, Dr. Srimati, Head of the First Year Department, Professor Reddy, and all my dear friends who were involved directly or indirectly for their constant support and motivation during the development of the virtual lab. Now, I would love for my students to come forward and share the learning experience they had during the development of this virtual lab. Yes, thank you. Thank you very much.
Hello everyone, this is Pratik, a third year engineering undergraduate student from IT department. It was very nice working with the whole VLab team. I was responsible for adding logic to all the animations. It was really fun in remembering all the chemistry formulae again. I would like to thank Vas ma'am for giving me this opportunity and for helping me grow technically. Thank you.
I worked on the front-end interface for the project, like creating all the forms and everything, creating all the front end of the project. So when it comes to engineering, like people think about it is only about technology, but for me, engineering is about solving the solutions, like solving the problems which are already existing out there. And this project could be a good example for it. I'm really grateful to Dr. Bhavna Vyas ma'am for giving me this opportunity, and it was such an honor to work with a team of such good developers. Thank you, ma'am. Thank you.
Good morning, everyone. Myself Prathamesh Shirarkar from PIT. I'm a full stack developer. I worked on the formatting and presentation of the content to make it look interesting and easy to update at the same time. I also got to implement the submission part. It was a great experience working in such a collaborative team. Working on this project was really an honor for me. I thank Dr. Bhavna Vyas ma'am and PICT for providing me with this opportunity. Thank you.
Good morning, everyone. I am Yash, and I was responsible for the JavaScript and and some of the animations. So, working on this project was really a unique experience for me, as this was the first professional project that I had ever contributed to. I learned many implementation-oriented programming skills and experienced firsthand what goes behind the development and deployment of software. The team was really very cooperative, and Vyas ma'am was very supportive throughout the project. It was a really fun and exciting experience. Thank you.
Good morning, my name is Farhan. Building the virtual lab has been an astounding experience for me. I got the opportunity to gain knowledge and dirty my hands by using the latest technologies. The entire experience gave me a deep knowledge of the end-to-end development of a professional project. Vyas ma'am and the entire team were so supportive and helpful throughout the project. I'm glad the end product is a masterpiece. Thank you.
Hello everyone, I'm Mansi Ganu, a second year student of PICT. Working on the front end of the virtual lab was an exhilarating experience. I got to learn so much throughout this journey, but just having a little hands-on knowledge of HTML, CSS, and JavaScript to learning and working on a completely new concept of SVG animation was a really good learning experience. We were in for a ride, a lot of brainstorming sessions, and multiple meetings later, this was the final product. Super proud of the entire team and thankful to Vyas ma'am for her valuable guidance and support throughout. Thank you.
So thank you everyone. And yes, could you please, sir, Dr. Director sir is right now in some meeting. Could you please start the speech of Srimati ma'am, because again she'll be having the meeting afterwards. So
Okay.
please, yeah.
Now I would like to introduce the principal of PICT, Dr. R. Srimati. She obtained a master's degree in electronics engineering from the College of Engineering Pune, Savitribai Phule Pune University, and doctoral degree in electronics engineering from Shivaji University, Kolhapur. She has a rich teaching experience of 30 plus years. She has been teaching, she has more than 40 plus research publications in national and international conferences and journals. Currently, she is carrying out a mega research project for a social cause funded by RGSTC, Government of Maharashtra, aimed at development of educational aids for speech and hearing impaired children. Principal ma'am It would be an honor if you share some words with us.
Principal ma'am, Srimati ma'am. I hope. Okay. She's having meeting. Okay. Fine. एक minute. Let me. Agashe sir has joined, so let me join him first. Make him a presenter. It's दिसत आहे आगाशे सर. प्रेझेंट करायला लागेल ना सरांना. सुधीर आगाशे. I'm adding Agashe sir as a presenter. He joined recently. She said. So I think Srimati ma'am I got the message. Srimati ma'am has a meeting, so she'll not be available for her speech. So could we go to guest of honors, Yash?
Yeah, sure.
Yes. I would like to welcome our guest of honor, Dr. Sudhir Agashya. He is currently a professor in COEP in the Instrumentation and Control Department. He is the principal investigator of Virtual Lab project of Government of India, Ministry of Education, under National Mission of Education through ICT. I would like to request sir to share us with a few words.
Yeah, good morning. Good morning. I hope you can hear me.
Yes, sir. We can hear you.
Yeah.
Yes, sir.
Yeah. See, what is important here is I have a pleasure to be part of this entire team of PICT when the request was made to us that we want to develop a virtual laboratory. And since the virtual laboratory project was started in 2009 with a consortium, we wanted somebody from Nodal Center also of COEP to contribute. What is important is you will find many institutions across the country who are using virtual labs, but there are very few who are interested in developing and making their expertise available to the entire fraternity of engineering education. So I personally thought that this is a good move and this is what has to happen in a long run. Then and only then we can sustain the project of virtual labs. If you cannot develop experiments at the grassroots level, things are not going to happen. And typically, Dr. Vash took the initiative. I must congratulate her and her team because the deliberations, what we had, the feedback which we gave, everything was accepted in letter and spirit and implemented. The enthusiasm of students is, I'm astonished with the enthusiasm of these students. And I hope that such type of enthusiasm can be shown by many colleges through their faculty members and students, so we can build a whole lot of virtual laboratories for the country. Because as you are aware that the new national education policy is being rolled out, and quite recently, last week only, we had a webinar wherein Prime Minister spoke about the initiatives of Government of India, and he talked about what is that which is there for education system. Our education system needs a change. Now that system in its current form is not going to sustain, we all are aware of. The number of seats remaining vacant, number of students not getting the job, the industry feedback, and so many things which are happening across or within the purview of engineering education. Uh, there is a concern which is being raised at Ministry of Education also. And it's like an oasis where somebody comes forward and say, yes, we want to contribute. We want people, those who are saying we want faculty members, those who are saying along with their students that, yes, we want to contribute. We want to do something. We want to do something differently, because the way our education system is being nurtured for last so many years, looking at the pandemic, we learned a lot, but in coming years, similar things are going to happen in industrial world also. The technologies are going to be obsolete, new technologies would come, and then where is the chance for a student to learn if he has not learned the learning to learn skill? These virtual laboratories will certainly give an opportunity for the students to learn on their own, and whatever help that group is required to uh, develop the labs and whatever help they require to host those labs, we are there. We are always there because we want good people to contribute. I congratulate the team PICT and the management of PICT once again for taking up this challenge, developing lab, demonstrating the skills, and then being part of this journey, which is at a national level. We are calling that journey as a transformation of Indian education system. Thank you so much, and I wish you all the best. Thank you so much. Thank you, ma'am.
Farhan, could you please call Professor Reddy? And thank you, Akashi sir, for your kind words. And really, it will be helpful for all of us. Thank you, sir.
Yeah, thank you, sir, for your valuable words. Now, I would like to call upon EM Reddy, sir, and please share us with his kind words.
Am I audible?
Yes, sir.
Yeah. So today's honorable chief guest, Dr. Guruswamy Kumaraswamy, Professor, Chemical Engineering Department, IIT Mumbai. Guest of honor, Dr. S.D. Agashe, Principal Investigator, Virtual Lab Project, College of Engineering, Pune. Director, PICT, Dr. P.T. Kulkarni. Principal, PICT, Dr. R. Srimati. PICT Chemistry Virtual Lab Team Leader, Dr. B.M. Vyas. And most importantly, the Virtual Lab team members, that is our students, and the faculty members of various colleges affiliated to Savitribai Phule Pune University. A very good morning and welcome you all for this wonderful program, hands-on workshop of PICT Chemistry Virtual Lab. See, there are many chemistry virtual lab experiments readily available on various platforms. But PICT Chemistry Virtual Lab is unique in the sense that it has all the experiments meant for first year engineering as per the syllabus structure of SPP, as Vyas Madam has mentioned earlier. Though we cannot replace the real experience of doing practicals physically, in this pandemic situation, this platform really helpful in doing the practicals virtually. It's like a blessing in disguise. This virtual lab is having many other advantages, like these labs help the teachers and students save their time and effort, as they don't have to adhere to a specific time schedule for doing the practical. Means it is more flexible. See, whenever and wherever, if you wish to do the practical, the virtual lab will permit. So the virtual lab helps the student to do the practical any number of times. See, if the student fails to get the desired result, and that experiment can be repeated, and it can be repeated any number of times, right? Till the desired results are obtained. So which is not possible, or it is very difficult in real life situations. So during practicals on virtual platform, it is very safe as you are not coming in direct contact with the toxic chemicals. But physical handling of these chemicals is also very important to develop that psychomotor skills, which we are going to miss on these virtual platforms. And if you are very eager to know what happens or what is the result for various inputs, then the virtual lab is the best platform to explore that. Means it permits you to do the permutations and combinations, and literally you can play with it, which is very dangerous in real life scenario, right? So I hope this PICT chemistry virtual lab will help the teachers and students of all colleges in general and affiliated colleges of SPPU in particular. So I would like to appreciate the efforts taken by the team members in developing this PICT chemistry virtual lab, and Dr. Vyas for taking this, for initiating this activity. So I hope you all will enjoy in doing the practicals on this platform along with the students. So wish you all the best. Thank you.
Thank you, sir, for your valuable words. Yeah. We are extremely honored to have Dr. Guruswamy Kumaraswamy as our chief guest for today. He completed his BTech in chemical engineering from IIT Bombay and then later pursued his MS and PhD in chemical engineering from California Institute of Technology. Dr. Guruswamy is currently a member of the group Pune Knowledge Cluster. He was also the elected fellow of the Indian National Academy of Engineering. Along with this, he has received many Blue Ribbon Awards, like R.A. Mashalkar Award for Scientist of the Year for the year 2012-2013, NCL Directors Commendation Award, NCL British Council Award, Ignite Program at Cambridge University, and many more. He has done lots of industrial collaborative projects in chemical and material sector, including GE Plastics and Reliance. He has also developed technology basis of agreements with Galaxy Surficants. Now, I would like to request Sir to share us with his valuable words.
Thank you very much. Firstly, I'd like to, can you hear me?
Yes, sir.
Great. So firstly, I'd like to thank Bhavna for inviting me to speak at this. It's an honor and a privilege to be able to do that. Of course, Bhavna is our student in many ways. She's an alumnus of our department at IIT Bombay. And she was also at NCL. Her PhD at IIT Kanpur was done in collaboration with my colleague at NCL, and I had the privilege of knowing her from then. So it's not surprising to me that to see the kind of enthusiasm that Bhavna has brought to this. So I'd like to begin by thanking Bhavna for inviting me, and to also start by congratulating the entire team. So Prathamesh, Prateek, Rohit, Farhan, Manasi, and Yash, outstanding job, outstanding, absolutely. So the pandemic has been an educational experience for all of us teachers, for sure. The of teaching online is something that somebody like me, I'm primarily an experimentalist, and I love classroom teaching. So it's something I took to rather reluctantly, and it's something which I've learned how to get better at it as the semester wore on. So there are advantages to the online mode and there are disadvantages. So as an experimentalist, I firmly believe that the joy of discovery from getting into a lab and doing an experiment, and really by that I mean an experiment where I do not know the outcome of the experiment, is the best way to get excited about science and engineering, right? So our current first year labs at IIT Bombay, first year incoming class at IIT Bombay is about 1400 students. And so to be able to teach a class of 1400 students is a very serious challenge, right? How do you keep them engaged and motivated and enthusiastic when they do chemistry or physics or so on, right? I mean, of course, a strong motivator is that you have exams and you get grades for those exams. It's not be and cannot be the only motivator, right? The best, most inquisitive students will come from engaged students who are engaged with the material, who are engaged in the process of understanding and using that knowledge to create new knowledge, right? And that only comes from being able to get your hands dirty, I think, as Farhan put it in his words. So in that sense, I think this effort speaks to those ideas at many levels. On the one hand, getting this group of students engaged with this activity, the people who are all the students who are engaged with creating the virtual lab, is in itself a wonderful exercise, right? Because it got these students, it got their creative juices flowing, it got them to do something and contribute in a substantial way during the pandemic. And I think that's effort and congratulations once again, Bhavna, for taking the initiative on this. So the other part of it is really to create a resource of lasting value, right? So like I said, doing chemistry is, teaching chemistry, learning chemistry is one part of it, but if you don't have a lab, then this is an excellent alternative. And uh, hello, there's some kind of an echo. Can you hear me? Okay, so just to continue, I wanted to sort of say that as the pandemic winds down and hopefully in a few months we'll all be vaccinated. I hope that we can go back to the lab, we can go back to regular online teaching, but also learn from this experience about the advantages of the online mode and use that sort of in conjunction with our regular teaching. So I'd love to be able to go back to the labs. I mean, to have students go back to the labs and do those experiments, but efforts such as this will have a lot of value for two constituencies. One is using these labs as part of online teaching. Because when you teach, it would be wonderful. I mean, lab that goes with it, but there's typically a time lag between when you teach and when you go to the lab. Having these would be a wonderful alternative in that context. This is also going to be a wonderful alternative for places that don't have the resources to do these kinds of labs, right? And there, I think if this is an alternative that is then widely available to them, then I think that something like this will have tremendous value. So this is really mostly from a user perspective. So once again, I'd like to stop this by both Bhavna as well as the entire team for an absolutely wonderful effort. And thank you once again for inviting me to be part of this. Thank you.
Yes, yes. Could you please go ahead with the next slide so that we can start the demo session? Yeah. So, with the permission of all, all the dignitaries and blessings from the Almighty God, now this chemistry virtual lab is open to all. So, yeah. Yeah, click on that. Yeah. Okay, yes. Yeah, so this is our PICT chemistry virtual lab, wherein we have this list of experiments. First is the analysis of water. So water related experiments, the determination of total hardness of water by complexometric titration method. Then the determination of alkalinity of a given water sample. Then regarding the pH metry, it's to find out the strength of a given acid by using pH meter. Then conductometry experiment. So by using conductometer, again we are able to find out the strength of HCl, and by titrating it against standard sodium hydroxide solution. Then the analysis of coal is the next one, which determines the moisture, volatile matter, fixed carbon, and ash content in a given coal sample. So it's a proximate analysis experiment. Then the next one is the spectroscopic measurements, wherein we determine the maximum absorption of wavelength. So wavelength of maximum absorption, lambda max, of a solution of KMnO4 using a spectrophotometer. And even in addition to that, we will be able to verify the Bayer's law, and also we will be able to apply it to find the concentration of the given unknown concentration of the given solution. And yeah, the last two are the related with the polymers and corrosion prevention. So polymers is a preparation of phenol formaldehyde resin, bakelite, and electroplating of the copper on an article of iron. So yeah, Yash, could you please slide that? So here after that, on the very first page, all our team members who have participated, who have contributed to this work are there on the first page. And yes, so today in the demo session, we will start with the first experiment. Yes, I'll share the screen from my end. Okay, so it will be easier for me. Now, I hope all the participants can see the screen. Manasi and Yash, could you please confirm?
Yes, ma'am, the screen is visible.
Yeah. So this is our, so all the participants, now let me show you the demo of all these experiments, and then you will conduct these experiments at your end once the demo session is over. Okay, so let me allow to do the first experiment, that is determination of total hardness of water and titration. Yeah, again, I'll request all the participants to mute themselves. Thank you. On this, and if we click the experiment related with the hardness, that is water analysis, will come in front of you, wherein the very first page will show you the aim, the learning outcomes, the apparatus required, and the chemicals required. So mainly the learning outcomes, as all we teachers, we stick to the Bloom's taxonomy and all. So we know that it's an outcome-based education, the importance of outcome-based education. So in this experiment, the students will be able to calculate the hardness of water. So they will analyze, and then they will be able to calculate the hardness of water. So after the aim, then the students can read the theory. Yeah, the theory related with this experiment, the hardness of water, what is the complexometric titration, which indicator is there, what is the, because here EBT is the indicator which is used. So areochrome black tea, which is a pH sensitive indicator, and EDTA solution, which is a complexing agent, that is hexadentate, since it's a hexadentate. And using the EDTA method, we are able to do the experiment. So the theory related with the hardness by EDTA method is given in this section. So now I know that in my participant list, there are a few people from the industries, as well as there are few people, a few other students, and mostly all faculty members are there. So faculty members know the theory very well, but the people who do not know the theory behind that, just for them, I'm just saying a few things related with this experiment. That hardness of water, basically hardness is defined as soap consuming capacity of water. But yeah, when as a layman, if I want to know the hardness, I say like this, कि भाई ये पानी थोड़ा hard लग रहा है. It means that there I can see somewhere some scaling or something like that. Even in the test, I say soft water है तो taste अलग है, something like that. So yeah, so to know the strength of that, to know the concentration of hardness, accurate hardness, EDTA is used. So EDTA and EBT, because EDTA solution, if we go for EDTA is a colorless solution. Water is colorless. If you mix these two things, that is also colorless because it forms a colorless complex. So that is also colorless. Hence, indicator is required. So EBT is the indicator which takes part in the reaction. So when we put EBT in the water, if water is hard, then only we will get wine red color. Otherwise, we can see the original color of EBT, which is blue in color. Because हम कहते हैं ना, पानी तेरा रंग कैसा, जिसमें मिला है वैसा. So when you put EBT, you will get wine red color if you have the hardness causing ions. Otherwise, blue color. So once if we get wine red color, basically that wine red color is due to the formation of complex, unstable complex, that is CaEBT and MgBT complex. And then when you add EDTA in that, EDTA being more sensitive towards hardness causing ions, what it does, it will replace all the Ca and Mg ions from that unstable complex, and it takes its position, like it forms a CaEDTA complex and MgDTA complex, and it makes EBT free. So again, if you go for the titration, what it will give you? It will give you the endpoint as wine red turns blue. So when you get the blue color, what we do? We stop the experiment and then we note down that what amount or what volume of EDTA which was consumed by that hardness causing ions. And then according to the reaction, we equate them and we get the hardness. So this is, there is no need to say or to all these teachers, but yeah, this is only for few people who don't know the theory behind that. I just mentioned few points related with that. And the hardness unit is milligram per liter. So the theory related with this, anyone, if you go to this theory, you come to know that, yeah, what is the hardness and how the reaction will occur, and everything is there in this theory. And yeah, let me clarify. This theory is not written by me. It's been taken from some references. So the reference section is also available here. You can see that in the reference section. If you click, there are various books which have been referred, and yeah, the theory part we have done. So on this bar, you can see that the aim of the experiment, then theory, then yeah, what I can do is I can, if I'm a student, go for pre-test, because something which is this test is the knowledge of the student, that which type of ligand is used. Because if I go to that theory, I will be able to understand. Yeah, fine, it's a hexadent test. So I click on this. Permanent hardness of water is caused due to what? It is caused due to the presence of bicarbonate of calcium, CaCl2, or magnesium bicarbonate, or none of them. So if I click, let's say if I don't know the exact answer, and just I'm saying it's due to the permanent hardness is due to the calcium bicarbonate. Yes. Okay, the answer is actually calcium chloride, but let me do it intentionally the wrong one. So let's say if I don't know as a student what is the permanent hardness, and it's just I say, okay, fine, that hardness is caused due to the presence of calcium bicarbonate, and then
Actually, your voice is breaking.
okay. So then the next one, the temporary hardness of the water is caused due to, let's say, if I take magnesium bicarbonate, then which of the following is not need hardness of water? So ppm, milligram, degree Fahrenheit, or milligram per liter. If I go for milligram, and then submit the test. So when I submit the test, yeah, my score will come, and I will come to know that where am I wrong. So my score is, let's say, 3 out of 4. So 3 questions I put it in a right way. So all you can see here, the green color is my right questions I have attempted, and the red one is I did that wrong. So I'll study it again as a student, because it is required. Because if I don't know what is hardness, what are the types of hardness, what's the fun in doing that analysis? So I should know the fundamentals quickly. Yeah, then I go for the procedure part, and this procedure is different than the procedure which we do in our laboratories when we do the experiments physically. So here we have to select and all. So since it's a virtual mode, the procedure is a little bit different. So I go through this, and yeah, once I go through the procedure, even the observations, the calculations, and based on the calculation, the hardness of water sample is displayed here on this page, and the result. So I can make use of this page again whenever I want. I can come back to this page. I can see the thing, and yeah, now let me go to the simulator to do the experiment. So if I go to the simulator, I think, are you able to see this page properly? Anyone can confirm? Yes?
Yes, ma'am.
Yes, ma'am, it's visible.
So, so the participants, this is the simulator which has been developed by our students. And let me tell you this thing, that during the development of all these experiments or simulators, we have made use of all cutting edge technologies. So when I say, if you, whatever the simulator you can see in front of you, here it's hard coded. So coding is very much backbone of the simulator. So if I, yeah, fine. Now let me say that. So now I can see that there are 3 sections in front of me. On the left side, it's a selection. On the mid of that, it's a titration unit, and on the right side there will be observation and result, so that I can see in front of me. So what I can do is I can select the type of water. So let's say if I want to go for tap water, I can select sea water, I can select well water. So I can select, so it's a user friendly, basically it's a user friendly. Let me select the tap water. And here also, the volume of water sample which we take in the conical flask is user friendly. Suppose if I want 10 ml as a volume of water sample, I can take 10, I can change 20, 30, 40, 50, up to max 100 ml, not beyond that. So volume of water sample is again user friendly. So I can make use of this volume and can do the titration. And yeah, again, the molarity of EDTA. Now, when we go for molarity, here also there is a selection wherein the students can select the molarity, that 0.01, 0.02, 0.03, and as per and n number of times he can do the experiment. Let's say first time he may go for the value of 0.01, and then he may go for value of 0.1. So based on his choice. So it's a user friendly. So yeah, the molarity right now we'll select the base one, that is 0.01. And yeah, here also the speed of titrant which is given. So basically this is why I have chosen, because generally we do the very first reading as a pilot reading, and then we go for the 2-3 sets. So over there in the pilot reading, I say, yeah, okay, fine, let me add 1 ml, 2 ml directly. So I can do that. If I go for like from 0.1 to last one is 1. Yeah, the speed of the burette solution, or the burette solution which is there in the burette, will come very fast. And if I go it for slow, it will come slowly. So let me right now set it to 0.1. And the things which are fixed in the experiment is your buffer solution and yeah, indicator EBT. So buffer solution, which is required, mandatory, because the complexometric reaction between that CADTA and MGDTA, that reaction will be complete. It should go for the completion. So it goes in presence of buffer solution, alkaline buffer solution, and yeah, indicator. So that is fixed. So we have kept it as the parameter over there. And now once I set this, the type of water, the volume of water sample, the molarity of titrant, that is EDTA solution, which is there in the burette, the speed of the titrant. Once I set that, what I can do is I can go to this start button, and once I start this, you will be able to see that the knob of the burette solution automatically will be open, and the drops of water, drops of EDTA solution will come down, and it will get mixed with your hard water. And yeah, simultaneously, even you will be able to see on the right side the color, the volume of the titrant used, that is the volume of the EDTA consumed by the hardness causing ions. So that will, so you can see that. Now if I start this, once I set all this left side parameters, then I'll say start, and you can see that, yeah, the drops of EDTA solutions are getting added to the reddish wine red color water wherein EBT complex is there. And yeah, now I got that endpoint. And now since, okay, fine, I'm little bit casual, and then, okay, now I'll say stop. So basically the volume of titrant used, if I don't stop at the endpoint, it will go on and it will show you the value increasing. Let's say my volume of titrant used or required to get the endpoint, if I cross beyond that, and if I do the calculation based on this 1.9, so this you might have seen that yeah, even the I reached the endpoint, and then also I added some more amount of EDTA, and by using that value, volume of titrant used, if I do the calculation, I may end up with some wrong calculation. So if I by using, let's say, from by using that 1.9 ml value, if I do the calculation, and that calculation part is already given in our procedure part. So if I do the calculation by using that 1.9, then let's say if I say that the value is suppose 190, for example, and say I know that I have done here a wrong thing, but let's say if I submit it, he will say your answer is incorrect, try again. So what I'll do, okay, fine, then I'll reset the thing, and then again I'll say start, and then I have to be very cautious, and I have to see that where is my endpoint, so that I will stop it exactly at that point to get the exact volume of EDTA used, because we need that accuracy. So yeah, at 1.2 I got that color change. So by using that 1.2 ml of volume of titrant, I'll do the calculation, and if I write the answer of that hardness, that is hardness of water, and if I submit, then I'll say, yeah, your answer is correct. Good. So in this way, I can vary the thing, and I can do the hardness experiment. And yeah, then if I, once I do this, I'll go for post test also. I'll do the, I'll solve this, and I can see that, yeah, whether am I right or wrong. I'll be assessed automatically. Okay, so in this post test, it's a little bit, the level is little bit high. So student has to study properly. Accordingly, he will get score based on this. And then, yeah, there are few assignment questions also which are given, so that just, yeah, what is hard water, why hardness is defined as like this, what is temporary hard water, the related stuff. So few questions based on that. And then, yeah, the next one is reference. I have already told you that the reference section is there, wherein we have referred these books. And then, yeah, the students can do the submission also, and wherein he will write his email address, then roll number, name of the student, email of the student, name of the college or university, aim of the experiment, the observations he has to type, he has to show the calculations, and then result. And then once he do that, he can submit the thing, so that a PDF will get generated. And he can send that PDF to his or her concerned teacher. So this is what our first experiment. Then if we go for the second one, alkalinity experiment, again the pattern will remain same. Only, let's say here aim, theory. Okay. Simulator, let me show you here. simulator, because here it's a phenolphthalein and methyl orange. These are the indicators that are required. So I cannot start it. Here you can see that this is deactivated. This button is not active. So once I select this phenolphthalein indicator, then only it will become active. And then you can go for your further process. And yeah, so here you can see that there are on the right side, there are 2 volumes of titrant used. That is V1, which we call it as a phenolphthalein endpoint. And then once that is over, automatically the second one, methyl orange, will come. And yeah, I'll show you. So once I select the volume of alkaline water sample, the volume of titrant, that is acid, which is used, then speed of titrant, then I have to set that indicator, phenolphthalein indicator. So, and then I say start, and then it will go down. Yeah. And then, yeah, once I get that color change, that pink color vanishes, because it's a phenolphthalein endpoint wherein we say pink color vanishes, you have to stop. And then you have to note down that V1 volume. That is, V1 is the volume of acid required for the color change or for the phenolphthalein alkalinity. Yeah. So similarly, once you get that, you have to then automatically the next step will be of methyl orange, and you can do that. And the entire experiment you can do at your end once this demo session is over, and you can check the result also. Once you do the experiment, you can check the result also at your end only. Okay. So right now, still here you can see that the volume of titrant used here, I'm seeing here it as a 5.5, 5.6, 5.7. So drop wise it is getting added, and simultaneously I'm getting the value as well along with the titration. So when the pink color vanishes, automatically my color change I can see, and then I have to stop immediately. Otherwise, again, that volume will go on increasing even if it is not required. So here 8.4, 8.5, and now it was colorless. Then the next, automatically the next indicator will come, that is methyl orange, and yeah, it will get added automatically, and then you have to say start. So what will happen, your volume of acid which has been added will get further added. So let's say if you got the endpoint, suppose 8 ml, then you 8.1, 8.2 will be there for your volume of titrant used for your methyl orange alkalinity. And yeah, again, yellow turns red will be your endpoint, and then you can do the calculation. Let me stop here. Yeah. So then once the experiment is over, yeah, I can enter the values as a result for phenolphthalein alkalinity and methyl orange alkalinity, and I can check also whether the answer is right or wrong. So that also I can do for this experiment. So here, since the speed of the titrant which is getting added drop wise, so it's coming here right now 13.3, 13.4. Even in between you can stop, and then again you can start. So that is not a problem. So it's much of like what we say is it's a user friendly. Yeah. So here it's coming 14.5, 14.7, 0.8, 0.9, 15, 15.1, 15.2, 4, 5, 15.6, 0.7, 0.8. Still I'm not getting the endpoint. Yeah. Now I have to stop, because and suppose if my endpoint was not 16.3 and suppose it was 16.1 or 16.2, then I may end up with my wrong results. So in that case, I have to repeat the experiment. I have to check properly where the endpoint is there, and at that endpoint only I have to stop. Otherwise, I'll end up with the wrong result. And yeah, you can see here the answers once you type that, once you do the calculation. So this is what about our alkalinity experiment. And then next, let's go to the next experiment. It's related with the pH metry. Yeah, in pH metry experiment, again, the pattern will remain same, only the content will vary. So here again, it is what we do is we find out the strength of the given acid by using, so it's a strong acid, strong base titration basically, but using pH meter, so no indicators. So theory related with that, the pH metry, the measurement of pH, the calibration, the neutralization reaction, the plot of pH, that is pH metric titration curve, everything is here. as a theory part. Then the pre-test is there, the procedure is there. So even you can one can read. Now let me repeat it once again. The procedure here is not the procedure which we do it in the lab, because it's a virtual experiment. So the procedure part will be little bit different. So wherein we say, okay, select the volume of HCl solution taken in a beaker. So for the to make it more user friendly, here the observations are there, the calculations are there, the results are there. So by to make it more user friendly, what we did is, like here again, we can, here it's written itself that volume of HCl taken in a beaker. So of course, since it's a strong acid, strong base titration, we have chosen it HCl as a strong acid, and volume I can vary. So let me start just for the demo part as the base value 50 ml. The normality also we can vary. Yeah, so normality also we can vary 0.01 to 2, 3, 4, like that we can vary. And the maximum value which you can take is 0.1. So 0.01 to 0.1. And yeah, here you can see on the in the simulator part is the setup, wherein the right side you can see that there is a pH meter, wherein the pH values will get displayed. There is a stand wherein your glass electrode is dipped, which is connected with your pH meter. And yeah, this is your burette stand along with that burette, and burette is having your NaOH. So normality you are selecting at your end. So once you select that, and when you say start, you can see that your experiment you are going to start. So now to make it more user friendly, sometimes it may happen कि यार मैं भूल गई वो procedure में क्या लिखा था. So what we did is we now you can read it on the top of the screen that what you have to do. So it's written here, click on the knob of the burette to start adding base. So if I do that, you can see that the base will get added. So let me do that. Yeah. So now you can see that because of that magnetic stirrer, you can see the swirls in your solution mixture, and simultaneously you can see the plot also based on these values, whatever are getting displayed on the pH meter. So pH of the solution versus volume of strong base, that plot is getting, that curve we are getting here, the three regions before equivalence point, at equivalence point, and after equivalence point. So we have to observe this. We have to observe this changing pH values on the pH meter, which gets displayed, and the plot we can see. And now once it's over, then again I'll say, yeah, click on the knob. So my experiment is over. And then what I can do is, even I can see the values here. Because what we do is, by using N1 V1 equal to N2 V2, we calculate the normality of acid. So from graph, we see that, okay, fine, at pH 7, what is the volume of base which has been added? So based on this, again, I'll calculate the normality of acid by taking the volume of base, okay, at equivalence point, because at equivalence point, H ions are equal to OH ions. So once I get this, by using that equation, I can enter the value here, the normality of HCl, and then the strength of HCl. Suppose if I take the volume as 0.01 here, and if I write here, suppose 0.365, and then if I just submit, just I'm checking whether I have done it right or wrong. So he said, okay, no, you have done it right. And suppose by mistake, if I do some wrong calculation, and if I say, let's say 200, something like that, and if I submit the value, it will say that, yeah, it's wrong. So you can do that, and again you can reset the thing, and you can go ahead with the experiment. So if you want to repeat the experiment again. So this is what related with the pH metry. So post-test questions are there. Again, these are your self-analysis that you will come to know that what is the score. Then the assignment questions are there. Based on this, you can understand his own knowledge, or by seeing the questions, he can make the subject well. Then the references, then the submission part. This reference and submission part is almost similar. So let me go for another one. So this is what about pH metry from our end. And yeah, this is the conductometry. The next experiment, the fourth one, is the conductometry experiment, wherein you can see that again the students will be able to use the conductometer and to determine the unknown concentration of the aqueous solution. So basically here we have gone for acid-base titration. So strong acid, strong base titration we have gone for. So the theory behind this is given here, and and all this theory, again I'm repeating here, the theory behind this, we have taken it from the reference book. It's not our own sentences. We have taken it from the book, and the references are given over there. So again you can go for some basic test prerequisite, which is there. We say pre-test, some pre-test questions you can conduct, you can attempt and submit the question, and then you will go direct. Then the procedure part, here also procedure, observations, calculations, and results are listed, so students can make use of this. And yeah, let me show you the simulator for this. Here, instead of pH meter, now you can see that there is a conductometer. So conductometer, here the volume of HCl will be taken in this conical flask, and the normality of NaOH taken is 0.5. And if I start this, so we have to start the knob so that your NaOH solution will get added, and you can see the swirls as well as the conductometric curve, that is conductance of the solution versus volume of strong base. You can see that on the right side of this, that simultaneously the plot you can see. And once the plot is ready, yeah, it will do the curve fitting as well for you, ready curve fitting. And you can see that the intersection of these two curves will give you the answer of, that is the volume of strong base added graphically. So this is obtained graphically. So okay, then yeah, since this simulator is doing itself the curve fitting and all, so let me what is my work is, I have to go on this point, that red point, and I can see that what is the amount of that is what is the volume of strong base which has been added at the equivalence point. So I can see this, and yeah, then accordingly I can write the answers. Here I'll not write, because you can do at your end once the demo is over. So right now my focus is to make aware that what is there in this software. So yeah, in this virtual lab. So again, once you have done with the experiment, you can go for post test, and you can check your knowledge based on the experiment. And like this type of questions are given, that suppose for a strong acid, strong base conductometric titration, before equivalence point, the conductance, whether it increase, whether it decrease, whether it remains constant, or none of the above. So this type of questions are tested once you do the experiment. And yeah, once it has been done, even you can, the next section is your assignment related with the conductometry, and then the reference section is there, and as well as submission part is there. So students can do at their end, and then whatever PDF which will get generated will be submitted to his or her concerned teacher. So your students will write their roll number, the name of the college, the name of the university. So everything is there in that form, in that PDF. And so the teacher will come to know that, okay, fine, this student has submitted, has done and yeah, he can assess him. And then yeah, the next one is let me go for the analysis of coal. So yeah, dear friends, this is really these two experiments, analysis of coal and spectroscopic measurements, really it was like really when we were developing this, lots of brainstorming session we did, and literally let me tell you that we worked in the night, right from 9 o'clock to 1 o'clock, 2 o'clock, and like that. And yeah, the analysis of coal now it's fantastic, which has been developed. So I'll not go through the theory and all, I'll go directly to the simulator part. But yeah, since it's there, let me show you the steps. Aim, so theory related with the coal, the proximate analysis, ultimate analysis, and how we do this analysis and all. But here I have restricted myself to the proximate analysis only. So you will not find the ultimate analysis part in this, as this experiment is related with the proximate analysis. So then you can give the pre-test, then you can go for the procedure, and the procedure is listed here, as well as you can see it in the simulator itself. And once you do that, you can go for post-test, then the assignment, then the reference and submission. So let us do the proximate analysis experiment. So basically here, since we know the various types of coal, so we have now liberty to choose the type of coal. So whether I can select lignite, I can select subbituminous, like I can select bituminous coal, I can select anthracite as well. So different types of coal, any type of coal, whatever I like, I can select that. So since let me start with the base, let me go with the lignite, suppose. And then once I select the type of coal, again, I have to mention the weight of air dried powdered coal. So here, basically in physically, when we do this analysis, we never go for a very high value or a big value, because it's an analysis. So we just move around like 1 gram or something like that. So I have kept 0.8, 0.9, 1, 1.1, 1.2, not more than that. So you can see that, yeah, max is 1.2. So you can choose any value, whatever of your liking. If you want 1, you go with the 1. If you want 0.8, you can go with the 0.8. And yeah, the things which are fixed, that has been listed on the left side. That weight of crucible is 23.64 gram. So the student, as a student, I have to note it down, that what is the weight of the crucible, the temperature of the laboratory oven, which is, because all these things in the theory is given. So temperature of the laboratory oven is 110 degrees centigrade, temperature of muffle furnace is 925 degrees centigrade, and temperature of muffle furnace for volatile matter content. Yeah, because for the volatile matter, to know the content of that, we need high temperature. So 925 degrees centigrade is maintained in the muffle furnace during that determination of volatile matter. While if I'm determining it for ash content, yeah, automatically my muffle furnace will take the value of 750 degrees centigrade. So you will be able to see the experiment. Now let me start for you. So see what we can see in front of our screen is a weighing balance. And on the top shelf, there is a crucible, there is a tong, there is a spoon, there is a coal sample, and even a vented lid, because for volatile matter we may require vented lid. So that can be there. Okay, so all these are there on our shelf, top shelf. And on the table, on the working table, what I can see is the weighing balance, the oven, laboratory oven. Then yeah, this is the mid one, small one, short one. You might have guessed it is a desiccator. And yeah, and the right side is a muffle furnace. So on my working table, all these equipments are there, all these tools, whatever I require, it is there in front of me. So now let me start the experiment. So when I say start, a screen will come in front of me, and it will help me. This screen itself will help me what I have to do. So do not go for hurry. Just do it slowly. Whenever you are doing at your end, just do it slowly, and just see the step by step, whatever is getting displayed, do that. And whenever you do, on the right side, the observation table will get filled automatically. So let's say when I say weight of crucible with coal sample, automatically that value will come. So right now he's saying that we click on the crucible to place it on the table. So just what is my duty is, just I'll click on this crucible, so automatically it will come on the working table. Then click on the crucible to weigh the empty crucible. So when I do that, you can see that a value is getting displayed on the digital balance, on the electronic balance. Whatever the weight of that whatever the weight of that crucible is, it will get displayed. So we have kept it fixed. So that is 23.64. So for each and every calculation, it will show you the same value, 23.64, which is a weight of your empty crucible. Okay, so now since it's a proximate analysis, I'll go step by step. So I'll go first with the determination of moisture content, then I'll go with the determination of volatile matter content, and then ash content. So so next is click on the crucible inside the weighing machine to take it out. So let me do that. I'll click on this. Slowly we should do. So click on the whole container now. So I'll click on this. So it will come on the working table. Then he's saying that click on the spatula. So I'll click on this. So my spatula will have the whole sample. And then he's saying click on the spatula again to add the sample to your crucible. So now this crucible is with your sample. So weight of crucible with whole sample is one of my reading, right? So it will get displayed. It should get displayed once if we go for weighing that thing. So what we can do is we can click on the crucible to weigh it along with the whole sample. So you can see that on right side here, the weight of crucible with whole sample is 24.44 because we have started with the value of 0.8 gram. Okay, so if I take 1 gram, if I select 1 gram, then accordingly it will come 24.64 because the weight of empty crucible is 23.64, which is fixed one. Okay, so the next is now since I have to keep it in the oven, what I'll do is I'll click on the tongs to take the crucible to the oven. So here also it's written that it's 110 degrees centigrade, which is maintained, the crucible, that oven is maintained at 110 degrees centigrade. So but I have to close the door. So what I can do is I have to click on the oven to close the door, and I have to wait for complete 1 hour. Okay, so now you will see, अरे मैम हमारा तो lecture है 12 बजे के बाद, because we are here up to 12 o'clock only. 1 घंटा कैसे रुके? So don't worry friends, since it's a virtual experiment, we'll just have to wait just few seconds. So once I complete 1 hour, then again I'll click on the tong to transfer the crucible to the desiccator, and then I'll click on the crucible to the weighing machine so that I'll get the value of weight of crucible with moisture free coal sample, because now already I have done with my first part. So moisture content I can calculate based on this value. So weight of crucible with moisture free coal it got displayed on the right side. You can see that. So it's 24.1328. So from 24.44 it got reduced to that value. So you can see that how we can get the moisture content. Okay, so that is there in your theory. And yeah, the next one is again click on the crucible to place a lead, because now we have to go for determination of volatile matter. So I'll restarting the experiment. Something went wrong. Okay. So let me do that. Click on the crucible, then click on the coal container. If some glitch is there, then it will automatically restart your experiment. So there is no point in of worry. So it will take it to the desiccator, and then after that we have to click on the crucible to transfer it to the weighing machine with the help of tongs. Now we'll click on the crucible to place a lead on it. So now the vented lead, now it will take this tong will take it to the muffle furnace, where we have to wait for 7 minutes. And here in muffle furnace, again, since it's a volatile matter, we have to keep it 925 degrees centigrade. So we'll click on the furnace to close it, and we'll wait for 7 minutes. So I'll do that. Okay. Speeds are problematic. I think it got hanged or what?
Ma'am, click on the furnace, like
Click
the
on the
orange part.
furnace.
Yeah, click on the furnace only to close it. Oh, I did the mistake. Okay, so I have to be careful, right? Click on the furnace again to open it. Yeah, thank you, students. Once it has been done, again click on the furnace to take it to the desiccator. Click on the crucible to take it to the desiccator. I think some speed issue is there, I think. Otherwise, it should go smoothly.
Ma'am, yeah.
Yes. Yeah, it's going. Okay, click on the crucible. Okay, so now here we got that on right side, the weight of crucible with moisture free as well as volatile matter free coal. Okay, so again that value got over there, it will get displayed automatically, which gets reduced from 24.13 to 23.91. So you can see the reduction in the values one by one in the steps. And yeah, the last step, again click on the tongs to take that crucible. And then we have to wait for half an hour for your ash content. And so what we do is we heat the coal sample in the muffle furnace for half an hour. So after half an hour, we have to click on the crucible so that it will get weighed, so it will get cooled down, and then click on the crucible so that it will get weighed and the value will get displayed automatically. So you can see that the weight of crucible with ash it got displayed on this. Now based on these values, now since I know the procedure, the observation and everything, I can have the result with me. So that I can do for the proximate analysis part. So once I do this proximate analysis experiment, let me go to the next one, that is spectroscopic measurements. So spectroscopic measurements, what I can see here, again the theory related with that, the aim of the experiment, learning outcomes, and theory related with that. Okay, the Lambert's law and all, the Bayer's law. So the theory related with that, even the instrumentation part is there's little bit the information related with that in this theory. You can see at your end once you have this link when it will get open to everyone. So now the pre-test is there, then again procedure part is there, and then then the simulator. So now, since it's a spectroscopic analysis, there are three parts that we'll be doing here. In the first part is your the determination of lambda max. Okay, so it's a wavelength of maximum absorption. That is our first experiment. So there will be three parts. First is determination of lambda max. Second is your verification of Bayer's law. And third one is to get the concentration, unknown concentration of the given solution. So that there will be three parts in this experiment. So what you can see on the display in the simulator is, and don't worry, everything, whatever is written on your screen, we have to follow that. So what I can see here is, yeah, there is a computer, a desktop, there is a spectrophotometer on the left side, wherein wavelength absorbance value will get displayed. There is a start button, we can start the spectrophotometer by clicking on that red button. Then what you can see else is on the upper shelf, there is a micro pipette, there are glass cuvettes, distilled water, and some sample which you will select. Okay, so now first of all, it's already mentioned that the wavelength range, whatever has been selected in this experiment, is from 400 nanometers to 700 nanometers. So this spectrophotometer will scan your sample in that wavelength range, 400 nanometer and to 700 nano. So in that that is your range, wavelength range, wherein it will study your sample. So I just blindly follow whatever he's saying. So it's a click on the red button on spectrophotometer to turn it on and wait for 30 minutes to initially. It's a normal procedure. So let me do that. Yeah, so now it's coming, the green color button, and yeah, I have to wait for half an hour. So even this watch helped me a lot. And then yeah, there's something new which came in front of me. Yeah, it's a select the concentration. It's written that select the KMNO4 solution, because here in this simulator we have chosen KMNO4 solution. So you can see that what is the concentration which is given here. Yeah, so there are 4-5 types of concentration which are given here. So you can select any one of that. So let me select this one, very low concentration, and I can see that the color of the solution, that KMNO4 solution, and that solution in that beaker on the right side. So here I can see that. Once I select that, automatically it will show me that KMNO4 solution with that concentration. And then click on the beaker now. So I'll click on this beaker, which is filled with selected KMNO4 solution, to bring it down on the table. Right now, what I have to do is I have to click on the empty crucible, because I have to fill it with this KMNO4. No? So I'll click on the empty crucible. So don't worry, friends, everything is written on the in front of us. So we will follow whatever he's saying. Okay, what that software is saying. So click on the micro pipette to fill it with KMNO4 solution. So yeah, I'll do that. And again, click on the empty crucible, empty cuvette to fill it with KMNO4 solution. So I'll do that, and that micro pipette will come on the top of that cuvette, and my cuvette will get filled automatically. Now, since it's a spectrophotometer, again, I have used the reference solution as a distilled water. So click on the reference cuvette, which is filled with distilled water on the top shelf, to place it in the reference holder of the spectrophotometer. So if I click on this, what it does is it will go directly and it will get placed in the spectrophotometer. Now, once I do that, because my KMNO4 solution I have prepared using the distilled water, so the reference solution I have kept in the spectrophotometer, and then click on the sample cuvette to place it on the sample holder. So here, this is my sample cuvette. So I'll click on this. So it will go and it will take its position. Okay. Now click on the knob on the spectrophotometer to close the lid. So I have to click on the knob of this knob on the spectrophotometer. So here there is a knob which I can see, the rounded shape. So I'll click on this. So now what I can see is my sample is getting analyzed by the spectrophotometer for a wavelength range of 700 to 400, 400 to 700 nanometer, and the value is getting displayed. And not only the value is getting displayed, what I can see is the plot of absorbance versus wavelength also for my selected KMNO4 solution. So this is my first reading. So first reading, I'm done with the first reading. So what I'll do is I'll click on the spectrophotometer to place the cuvette back in the shelf. So I'll click on this and automatically they will go. And now what I have to do is, I can see that I can select the different concentration one by one from the drop down menu, and I'll click on the monitor to observe their plots one by one. So we have already seen with that 0 point for this concentration. Now I'll go for the second one. And what I can do is I can say select different concentration. So I have selected this 0.001 molar concentration KMNO4 solution, and then click on the monitor to observe their plots. So if I click on this, I can see that for 0.001 molar solution, if I select, how will be the absorbance versus wavelength for that KMNO4, for that sample. Okay, so for each and every different sample, I can select and I can see that the absorbance versus wavelength plot for each and every. So now for this second sample, I could see in front of me in the on my desktop, which is kept on working table. I'll select the third sample and I'll click on the monitor here. So whenever I select some sample, I can see the absorbance versus wavelength of that particular KMNO4 solution. Okay, so then because there is no need to repeat the thing again and again, because I know the procedure. Since I have done my first reading, I know very well what to do. I have to take the KMNO4 solution, I have to take the cuvette and the still water, everything. And yeah, so that's why for different sample we have gone like this, that you can select the different concentration one by one and then click on the monitor to observe their plots. So their plots means absorbance versus wavelength plot of a particular that KMNO4 solution which you have selected. Okay, so I'm done with this also, and let me check with this also, the last one, and let me click here. And what I can see is I'll get the plot for that 0.004 molar concentration, the absorbance value versus wavelength. And in addition to this, what I can do is now, if I click on this monitor, I can compare the graphs. You know, friends, till now I have done with the 4-5 different samples. If I do this, I can see that they are on the top of one another. Okay, about like, so let's say if I compare for all these concentration, what I can observe is the absorbance value is getting increased with increase in concentration. So, and even another thing from this, what I can note is I can note down the lambda max from this plot, because the lambda max value, okay, if I observe it closely for a particular sample, that lambda max value, I can note it down. And what I can see is the lambda max value remains same. So which is a characteristic value of a particular solution. So I can note down this lambda max value from this plot, which is the maximum one. And for each and every sample, I'll get the same lambda max. Okay. So once I do with this, again, what I can do is I can now go for the verification. So to start the verification of Bayes' law, I can click on the spectrophotometer and it will get displayed as verification of Bayes' law. So to verify the Bayes' law, click on the monitor to check the absorbance at lambda max versus concentration graph. So these values, like at a particular lambda max, so I'll select that lambda max, and for that lambda max, I'll plot a concentration. Okay, I'll plot the value, for the verified Bayes' law, I'll plot the absorbance versus concentration of whatever sample we have done. So when I do this, and if I go for curve fitting, I found that it's a linear curve which is getting fitted. So I can conclude, yeah, I have verified the Bayes' law. So virtually also we can verify the Bayes' law fantastically, okay, in a very best way. And now what the third part, what I can do is click on the spectrophotometer to find the concentration of unknown solution. So I'll do this. So my third part of this experiment will come. So wherein now I have to do the experiment because it's an unknown solution. I don't know what is the concentration of that solution. Okay, so as a participant or as a student, I don't know. I want to check iska solution kaisa hai. So what I can do is I can use the plot of concentration. I can use the plot of absorbance versus concentration wala plot, and I'll do the experiment first. And then whatever absorbance value which I'll get for KMNO4 solution, I'll go on this plot. I'll see to that ki wo absorbance kahan hai, and then I'll take a line from that, and wherever it crosses my linear line, this on this concentration absorbance versus concentration curve, and I'll drop down. So I'll make a parallel line. So wherever it is cutting, from that point I'll come down. So I'll draw a line parallel to the y-axis, so that I can get the concentration of the given solution. So unknown concentration I can find out by using this plot. Okay, so but for that matter I have to do the experiment because it's a different solution now. So here again, no worries, because everything is there in front of you. He's saying that click on the beaker, I'll do that. Click on the beaker to bring down the KMNO4 solution. So but right now I do not know the concentration. So I'll just, I'm really excited to see that what is the concentration here. So I'll click on the empty crucible, empty cuvette, and I'll click on the micropipette to fill it with that unknown concentration of that KMnO4 solution. So, and I'll click on the empty cuvette so that it will get filled with that solution. And then again, this procedure, I'm repeating this because it's an unknown concentration, that's why. And then click on the sample cuvette so that it will take its position in the spectrophotometer. And yeah, then I'll go for the knob. Here you can see in the spectrophotometer, there is a circular knob here, oval shaped knob here. So you can click on the knob of that spectrophotometer to plot that. And yeah, now you can see that the value which is getting displayed on the spectrophotometer is that the wavelength is at 528 nanometer wavelength. The absorbance value is 0.5. So for this sample, it is showing that the absorbance is 0.5 at 528. That is the wavelength which we take it out, okay, from the previous experiment. So now once I do that, yeah, then I can make use of this, and I'll go here 0.5 to this. I'll go here and I'll see that, yeah, fine. Yeah, for 0.5, my concentration is 0.002. So this is the concentration of my unknown solution. So I can note down the concentration, unknown concentration, from this graph using the absorbance value, which gets displayed here on the spectrophotometer. So this is what about this experiment. Okay, so once it's done here, it's done. I'm done with the spectroscopy experiments, all three parts. And yeah, the last two are very short, friends. They are just since it's a study type of thing, the preparation of phenol formaldehyde resin. So again, the pattern is same, aim, theory, and this pattern we have done it in like we have followed the same protocol which is there at the MHRD website. So MHRD Virtual Lab, because we are also under the process to upload this. And yeah, Dr. Subir Agashe is helping us in the process. Yeah, and so the same thing for phenol formaldehyde resin, I'll go directly to the, yeah, there will be pre-test, there will be a procedure, everything is there as it is. But here, since it's a resin, the experiment is just pink color solution will get formed. So just again here, we can see that how the steps to do. So no need to worry again I'm saying, because it's a very user friendly, whatever, I'll not get confused that okay, I'll not get confused because the things are coming in front of me, so it helps me. Okay, being a human since we are human being, we may forget something. So yeah, the things, if they are there in front of me, it's comfortable for everyone. So you can see that here it is written, take out the beaker from the shelf and fill it with 100 ml of water. So I'll go and I'll click it here. So and then he's saying click on the acetic acid container to bring it down to the table. So I'll search here. Yeah, here it is a acetic acid container. So it will come down on my working table. Then I'll say, okay, fine, click on the measuring cylinder to add exactly 5 ml in the beaker. So if I do this, what it does is it will take automatically the 5 ml of acetic acid and then it will pour down in the beaker. And then click on the phenol formaldehyde, click on the formaldehyde bottle to bring it down to the table, because it's the next one what we do is that. Then click on the measuring cylinder. Okay, so automatically it will take the amount and then it will get added in that beaker wherein you have poured already the acetic acid. Then the next step is click on the phenol container. And yeah, our software is also very clean. Whenever things which are not required, it goes automatically and will take its own position on the shelf. So only the working table is always clean. So whatever things are required, that will, you can see that, okay, fine, phenol is required, so phenol bottle will be there. And since phenol is there in the powdered form, we need a spatula. So automatically the spatula will come and it will take the phenol from that bottle. And if I do this, if I click on this spatula, it will get weighed, because I should know that yeah, 2 grams of phenol I have to add. So the electronic balance will display the value that what amount of phenol is been taken. So again, I'll click on the spatula, so it will take the sample and it will put it in the beaker, and then click on the concentrated H2SO4, because we need this. Yeah, so I'll go for close. So as I mentioned that if some any glitch is there, again it will restart the thing. So click on the beaker, click on the acetic acid, sometimes maybe because of the speed and all, some issue can come, but yeah, again it will reset on its own. So we have to be patient little bit, because it's a virtual, so sometimes it may happen. Okay, so click on the acetic acid container to bring it down on the table, click on the measuring cylinder to bring. Okay, and then the next one is click on the formaldehyde water, then click on the measuring cylinder to add 2.5 ml of formaldehyde solution. So formalin, actually it is formalin. So click on the phenol container. Okay, then click on the spatula to collect the phenol from the container. So I'll click on this spatula. So it will take the phenol, but we have to weigh that. So we have to again click on the spatula so that we can know the 2 grams of whole phenol we have taken. So again, if we click on the spatula, it will get transferred to the beaker. And now click on the concentrated H2SO4. So I'll go for this. Okay, so if it does, again it will take it to, but after addition of the H2SO4, you will see that a pink color resin will get formed. Okay, yeah. So the last one, which is electroplating. So again, you can see that electroplating. If I click on it, I'll go directly, since time is less, I'll go directly to the simulator. And yeah, all friends, once after this, you will be able to conduct at your end, but do it slowly. So whatever is getting displayed, do it accordingly, and you'll be able to conduct the experiment virtually in a best way. So here it's an electroplating experiment. So weighing balance is kept on the right side, and the things which are required are on the shelf. So take out the beaker. So a beaker containing water, US solution, put that which is containing space of substance will come out. Then click on the weighing machine, turn it on. So let me do that. So it will be out on. So click on the spatula to play the US for. So automatically we have weight perfectly. So weight is something 9.9. So yeah, it's a big weight of separate. So click on the spatula again so that it will go and it will get mixed with the water which is kept over there. So you have the food solution. So click on the glass rod because it will not be glass rod. So that's yeah. So you can see that blue color solution is getting formed. So now click on the sandpaper. So sandpaper is here. So I click on so that it will clean my article. So it's an iron nail. So it's by using the sandpaper and cleaning my iron nail. And yeah, as well as the material. So it's now what we do is that is here. If I click on the battery because I need battery, so battery will also come on the working table, and click on the copper metal plate because I want to deposit this as a coating. So I click on this copper metal plate. to connect it to the positive terminal of the, yeah, this is important, right? Physically, when we do that, when we say to all the students, right? Yeah, they can't connect it to the positive. So our should be connected to the positive terminal. Yeah, so yeah, then we'll click on the icon and of the profile scripts. So yeah, now you can see that after some time your iron will become have the coating of the, you can see here, that it's got coated. So we are done with this electroplating. So we can so this is the last experiment in the PICT chemistry laboratory. So team members, as I mentioned, so it's not just one person who can do. You just when I say one thing,
that only water molecule will pass through this silicon.
So all my students here are there.
Allow
This along with me. We are there here. Basically, the main objective is to serve the people. So so that even if at any point of time, if someone wants to conduct the experiment at their end, let's even if I'm thinking, okay, problem arise. Let me do it again. So n number of times we can do that. So so and basically, really, I thought it was a problem for me during the lockdown. So the PICT chemistry lab in front of you as a product, and yeah. So once it's displayed on the MHRD website, it will be open to more a wider audience. While right now also anyone can access this lab. So what I do is yeah. So thank you very much. First, let me thanks everyone. Thank you very much. The vote of thanks will be given by Professor Dr. P.G. Umape, and yeah, after the vote of thanks, we will have this link in the chat section. All the participants can click on the link and can access that chemistry, PICT chemistry virtual lab. So yeah, I request Mape to give vote of thanks. And there are two things. One thing is after thanks, you will see that in the section, the feedback link as well as the lab. So first click on the lab. Once you click on the lab, you will access that lab. All participants can access the lab and they can conduct the experiment at that. Okay. So at any point of time, any problem is there, please let me know. We are there here to serve regarding whatever questions which are there. So that's it. So from my end, this is thank you very much. And really, I'm very much delighted that all of you have come and you have attended. And yeah, the main thing is the support which I got from all my teachers, all my colleagues, the management, and really, it's by doing this, while developing the lab, एक different level का satisfaction मिलता है. एक कोणत्या तरी वेगळ्या तेव्हा चालू करतो तेव्हा इतकं मोठं होईल का. Then it's my attitude, it's my nature. Nice, but at least we'll learn something, right? So at that time, that was thing in my mind. Just once it is over, now really I'm very happy to share this PICT chemistry lab to all of you. And yeah, it will be in the chat section after vote of thanks. So yes, please put the slide of vote of thanks so that Professor Umape will take from that. I unshare my screen. So now I yeah, yes, please
Yeah,
on that, right?
Dr.
Yeah.
P.G. Umape will now propose a vote of thanks.
So, am I clearly audible? Yes. Yes. Am I audible?
Yes, sir, your voice is breaking.
Is it good now? Okay. Is it good now?
No, sir, it's still breaking.
Let me just issue. Uh, okay. I am audible. Is it clear? Issue is there. Please reply.
Uh, so maybe there's a mic issue because your voice is still breaking.
Okay. Is it okay now?
Yes, sir, it's better.
Okay. So, thank you, Vas Madam, for giving me an opportunity to express the vote of thanks. On behalf of AICT, myself, Dr. Prashant, in this morning and inspiring us. I will also sincerely thank Dr. S.D. Agashi for his presence and take this opportunity to express my heartfelt thanks to our director, Dr. P.T. Kulkarni sir, a dynamic and disciplined person, and always encouraging us to try some innovative methods of teaching for the student. I express my gratitude to our principal, Dr. R. Srimati Madam, for moral support, guidance, and encouragement in all efforts. I express my gratitude to our beloved HOD, Professor Ian Reddy, for his moral support, guidance, and encouragement. I am happy to extend a hearty vote of thanks to our managing trustee, Sri R.S. Kotable sir, Sri Swastik Sikar sir, Secretary SCTR. Finally, I owe a special gratitude to our PhD student team who have worked very hard in making the virtual lab a very innovative and interactive for the students of first year. Thank you all for your presence. Thank you.
Okay, so now let me give the link to everyone in the chat section. So in chat section you can have the link of chemistry PICT chemistry virtual lab. Wait a minute. Okay. So now let me give the link, and this link you can open at whenever you need, whenever you want to do the conduct the experiment. Okay, so here is the link. It's getting opened. If I go for copy the link, yes, and here, okay. So all the participants can now click on that link to access the lab. Yes. And yeah, thank you very much for your participation. And yes, any difficulties, anything which you would like to share with us, you are welcome. But virtually, online. So yeah, another thing is, Kute. Okay. Yeah, I got this. Yeah, and student and all the faculties are all the participants. Please feel the feedback. Okay, your feedback will motivate us, and yeah, and will your e-certificates we will give you shortly. So this is the feedback form link. So you can fill the feedback form. So there are two things. First you conduct the experiment, and by using the feedback form, yeah, you can give your feedback to us, all of us. So we'll receive your feedback. Okay. So now, yeah, chat section. So let me have some of the feedback from in the chat section, which I can read it from this. Yeah, sometimes voice is breaking. Okay, the things which are not there in our hand, we cannot do anything. But yeah, we will try our best to because all these are internet-based things, right? And then is it possible other college student can access this less? Of course, it is possible. All the students, any one of you, anyone can access this lab if they have the link with them. So now I have already pasted the link. So you can take that link and keep it with you. So whenever you have that link, you will open that link, the lab will be accessible. So anyone can, having that link will be able to access the lab. Okay. So yeah, informative session. Thank you. Yeah, thank you. Congratulations, Dr. Vyas and team for development. Thank you, sir. Thank you. Excellent session. Yeah, yeah. If any queries there, then I will no. Everywhere, all the congratulations and all are there. Yeah, impressive presentation. Okay, thank you, sir. He's a person from industry. Yeah, yeah, and yeah, thank you very much, all the participants from PICT, and yeah, and being right now the pandemic is going on only, but then also we have the control because we have vaccines now with us, the Indian vaccines, and yeah, in very shortly we all will get vaccinated. So till that time, please take care of everyone. And your certificates, and you will get the certificates once we get your feedback form. So the feedback form, whosoever will fill will get the certificates, and the registered candidate plus feedback form will be the eligibility for the e-certificate, issue of the e-certificate. And thank you very much. Thank you. So I will again at the end, I'll thanks everyone, our chief guest, director, as already vote of thanks given by Professor Umape. Yeah, all my chemistry faculties from our department. Since I am being a first year department,
Yeah, my head of the department, as well as my chemistry faculties, all my friends like chemistry faculties, Abhishek Kulkarni, Umape sir, Gawale sir, all are, we are together, and we are presenting you our PICT chemistry virtual lab in front of you. Yeah, please utilize the lab and make use of it. And shortly, the lab will be on MHRD website. Thank you. We need your blessings. Thank you. Thank you very much. So I'll end the session here. Thank you.